So students, after performing that activity, we have come across the point that matter is particulate in nature. That means it contains fine particles which are billions or millions or billions in number, right? Even though if it appears a very small quantity, but still it contains millions of particles in it, right? So depending upon that, we have here characteristics of particles of matter. That means what is their nature, what are their properties, we will be seeing in this video. The very first point is particles of matter have space between them. Just now we have performed this activity and we have seen that when salt, Dettol or any other sugar something was added to water, it got mixed with it in such a manner that the level did not rise, indicating that even though the container was appearing to be filled with water, but still it had got spaces between the molecules of water, due to which when salt or Dettol or sugar was added to it, those fine particles, those minute particles adjusted themselves in these minute spaces. Yes, those spaces are not visible to us, we cannot see them as they are very minute, or you can say microscopic. Hence these fine particles adjust themselves without being detected. Hence we can say that particles of matter have space between them. Another example, I'll give you one more example. For example, when a person is swimming, right, swimming in a large pool, so what happens there? The pool appears to be filled with water, right? And since already water as a matter is present in that pool, we think that nothing can enter that one, right? If some space has been occupied by some matter already, no other matter can take that place. This was the thing that we have come across in this chapter. But here you'll observe that as the person dives into the water splashes. That means all the molecules get adjusted or get arranged in such a manner that the person can fix it himself in that water, can allow himself to move. As the person waves his hands and legs start moving in water, the movement of the molecules will also start, molecules of water will also start, due to which they start adjusting themselves in such a manner that all the particles, I'll show you here, it is like this. The particles are present like this, right? Water molecules, they appear very close to each other as we are seeing them, but you can observe that there are spaces between them, right? There are minute spaces, though they are not visible to us, but still they are there. So when anything comes into this one, when anything tries to adjust itself into it, then what happens? These molecules start arranging themselves. They start arranging themselves in such a manner that they will create space for that object here, and they get, you can say, condensed or compressed in particular area. All these minute spaces will be collected at one place, so that whatever that is coming inside, whatever the object is that is entering inside, can be allowed to do so, right? So in this manner, particles which are particles of the matter, if matter here we are considering water, even if it is appearing continuous, it's not, spaces are present in it, and something enters it or tries to get into it, then they will adjust those spaces and allow that object to enter into that matter, right? So we have seen here how particles of the matter have space between them. We'll move on to the next one. So the next one here is particles of matter are continuously moving. How is it possible? How particles can be moving from one place to another? So Here see, for example, if you are seeing a bench or any other kind of object is there, then at that time what happens, whether it's a solid, liquid or gaseous material, the particles that are present in the matter, they show vibrations, right? There are vibrations between the particles. These vibrations are so small that they are not visible to us, but still they lead to the movement of the matter. They lead to the movement of the particles of matter. For example, incense sticks. Incense sticks, that means agarbatti, right? What happens here is, when you light up an incense stick, you'll put it in one corner of the room, right? But when it starts burning, the smoke coming out of it will spread in the whole room and you'll get the smell, right? The fragrance will spread in the whole room. So this is happening because the particles, the fine particles of the incense stick are burning, and in the form of smoke they are spreading in the whole room, due to which the fragrance can be detected in every part of the room. Now, unlike that you have put it in a corner and the smell will be coming in that corner only, no. As this smoke spreads, you'll get the smell of that material everywhere in the room. Similarly with food also, right? If something is being cooked, right, so you can get its smell from a long distance also. That means here particularly the smell of the hot food that is being cooked or had been cooked, you can get its smell from a long distance. But in case of cold food or beverages or any other kind of edible substance like ice cream, you cannot detect its smell from a long distance. But the same thing is possible with hot food. If something delicious is being cooked, just by detecting its smell you can come to know that it is a delicious food. The same thing is not possible with ice cream, cold drinks or any other kind of cold food items. It is because the particles of the matter, even though they are moving continuously, they require kinetic energy, right? The energy that is present in the moving objects, kinetic energy is required, and that kinetic energy is obtained by vibrations of the particles, and those vibrations are obtained by temperature. Very important point to be noted, temperature. See here, incense stick example we have taken, hot food items example we have taken. In both these cases, the matter, the substance is at a higher temperature, right? Due to which the smell, the fragrance can be detected from a long distance. But in this case, in case of cold food items, the temperature is low. Hence, particles cannot move easily. They cannot travel longer distance. So we come across the point that the particles move. They travel longer distance. Longer distance will be traveled by particles at high temperature. Particles at high temperature. But the same is not possible with particles at lower temperatures. So thus we come across a very, very important definition, that is diffusion. So what is that? So what is the definition of the diffusion process? How is it affected? On what factors does it depend? We'll see in the next video. For today, write down the heading, put these points. No need of drawing or explaining all these things. If you want, you can take the example. You can just mention the example like swimming pool, man diving in the water. Here example, incense stick, food items, like that. No need of explaining all these things, right? So that's all for today.